In activity 23, we're going to be talking about the two laws of our trig functions. So 23-1 talks about the law of sines. So we're going to apply this to solve some problems today. So open up your Springboard book to page 319. Make sure you have something to write with, and you also need that scientific calculator so you can do our trig functions. Okay? So this lesson starts on page 319, but I'm actually going to skip to the next page here where it actually tells you what the law of sines is. Okay, so we are going to use the law of sines when we're trying to find the side lengths of triangles. Now, if we look at triangle ABC here, you notice that this is not a right triangle. So we can't use things like Pythagorean theorem or anything like that. So instead, what we have is this law of sines, and it's proven on this front page. We're just not going to go through all that for today's lesson. I'm just going to show you guys how to use it. Okay, but if you're given, say, two angles and a side, or two sides and an angle, you can use this law of sines to find those missing kind of pieces. So in law of sines, we can take any of these two proportions and set them equal to each other. So it kind of depends on the problem, what you have to work with and how you're going to set it up. But when they're talking about sine of capital A over little a, that's talking about capital A is the angle, so it's the sine of that angle, divided by the opposite length. So you can notice they are labeling little a as a side of cross from angle A. Okay, little b is across from angle B. Little c is across from angle C. Okay, so it kind of depends on what you're set up with. So the sine is always going to be of the angle. Those lowercase letters are the lengths of those side lengths. Okay, so in this problem here that they have, you're trying to let's see, what is the distance between A and the fire? Forget where the fire is on this problem, but okay. The fire's at station C. So they want to know what's the distance between A and C. So you're solving for B in this particular problem. Okay, so what they did is they used what they know. So they know the side length of C. So you're probably going to need that. Now, when we have a triangle, and we know it's 42 and 44, we can use our law of the 180 degrees to find that missing angle. So you might always, if you're given two angles, I would always find the third one, but they have 94 for that. Okay, so to use this law of sines, they're going to use angle C and side C, because they have those. And then since they're trying to find B, they're probably going to use the sine of B. Okay, so if they set it up, we have sine B over B is equal to sine C over C. So again, in this law of sines, you just have to see what you're given in your problem to know which two kind of proportions you're going to work with, because you only need two to solve the problem. Okay. Then when you set it up, I would cross multiply these and then get your variable by itself by punching everything in the calculator, solving, and make sure you round to whatever they say. Okay. Now let's go through a problem from scratch. So it says two boaters located at point A and B notice a lighthouse at point C. What is the distance between the boater located at point B and the lighthouse? So again, the lighthouse is at point C here. They want to know what's the distance between point B and C. Maybe we'll just highlight that. We're trying to find this distance here. Okay. Now again, if I label these, so we have, this would be little side A, so it's across from angle A, little side B, across from angle B, and we have little side C across from angle C. So let's see, if we're trying to find, we need to find A, so I'm going to use angle A and side A. Now I know the length of C, so I probably need angle C. But now let's think about it. If we have 48 and 55 as my other two angles, what does that make angle C? Well, if we take 48 and 55 and add it together, okay, and subtract it from 180, we should have 77 degrees left over for angle C. So here's how we can set up our law of sines. So we have sine of A over A is equal to the sine of C over C. And again, I'm using those proportions because that's the information I'm working with. That's what I have to go off of. So let's see, we have sine of A, so that's sine of 48 is equal to, I don't know what A is, that's the side we're trying to find, equal to the sine of C, which was, there's C right there, which we found out was 77, over the length of C, which we said was 1.5. Okay, so now our goal here is to solve for A. I'm going to move my work, I think, over here so I can see it a little better. Okay. Okay, so if we cross multiply, we have 1.5 times the sine of 48 equal to a times the sine of 77. Now, if I just want to solve for a, I can just divide this out. Okay, so a is equal to 1.5 times the sine of 48 divided by the sine of 77. So the rest of this we need our calculator for. So I'm just going to do 1.5 times the sine of 48. Now I'm probably just going to do this in 2 steps so I don't mess up anything. There's that. So then I'm just going to divide that answer I got by the sine of 77. Hit enter. And that's what we get for B. So B is about 1.14, or A, I guess. 1.14. So that's the distance between the boater, kilometers, and the lighthouse. Okay, so again, look at the information you're given and set up those proportions. Again, you only need 2, so it helps me to label the side lengths across from my angles. That way I know which one goes with which number, but however works for you. Okay, so let's try one. We're going to try 7a. They want you to find YZ. So let's maybe, YZ. They want you to find this length. So let's label this as little x. We got little z and little y. So if that helps you. Now, again, I would find that third angle first, then use that to set up a proportion. Okay? So let's see. We have to find YZ that we need to know. We're using sine of x over little x. And let's see. What else do we know? Well, we know the length of little z, and we know the angle for little z. So let's do sine big Z over little z. So there's kind of your setup. Now plug in your numbers, and you guys find, what do you get for YZ? What's the length there? Let's say round to the nearest tenth. Okay, if you did it correct, I got 13.9. Okay, so sine, we'd have to take sine of 75 over x equal to the sine of 44 over 10. Cross multiply and do all the work in the calculator to get x. All right, let's look at B. Now B is going to be a little trickier because we only are given one angle. So look at this math tip really quick over here. It says you may need to use the law of sines to find an angle measure before finding the length of the side. Okay, so if they want us to find DE, okay, so let's call this side little f, we got side little d, and we got side little e. So if I'm going to use the law of sines here, I probably can use d, use the sine of d over little d. And if I have to find DE, that means I have to know the sine of f. We'll call that little f. Okay, so right now I know the sine, I know the angle D, and I know the length of little d, but I don't know either of these. So that's what they're saying, is you may need to use the law of sines to find this angle first before you can actually solve the problem. So let's look at what we're given. We're given angle E, or side of length of little e. So maybe we can use the law of sines to find E first, which would then help us find F. So here's our kind of little side project we have to do. So we have the sine of D, so 125, equal to the little d, so across from that. Equal that to the sine of E, which again we don't know, but across from that would be 8. So there's your little e. Okay, so let's find out what our angle is for E here. Let's cross multiply. So we have 8 sine of 125 equal to 10 sine E. So divide out the 10. I don't know what's happened there. So we have 8 sine of 125 over 10. That's equal to the sine of E. Now remember, anytime we're finding the angle measure of something, we have to use the inverse trig function. Okay, so let's use that. So we have to find the inverse trig function, so inverse sine. I'm just going to put this numerator in parentheses, so 8 sine of 125 divided by 10. We'll close that parenthesis. So let's see, what do we get for E? Okay, so let's round that to the nearest degree. We'll say E is about 41 degrees. Okay. So now that you know what angle E is, we can find angle F by doing just a little subtraction. So if we have 125 and 41, that's 166. So let's see what's left over. Okay, angle F then is 14. Okay, so now we know everything we need for this problem. We have the sine of D, so sine 125 over little d, which was 10. The sine of F, we just figured out that that was going to be 14 degrees, okay, over little f. So that'll help you find DE. So you guys finish this problem. What do you get for the length of DE, aka little f? Okay, if you did the problem correctly, you should have gotten 3 for the answer. Okay, if you're off by a little bit because of rounding, no big deal, but just make sure you're close. Okay. So again, the law of sines is just using two proportions. So you're using the angle measure and then the length across from that angle. Okay, and setting up two proportions to kind of help you find those missing side lengths. And again, we have to do all this work because these are not right triangles, so we can't use Pythagorean theorem anymore unless we have a right triangle, which in this case we don't. Okay, so there is our law of sines.